on time this time. And also I want to thank everyone for attending the first annual OCAP workshop. This is on capability flavored effects. Our speaker is Aaron, and I'm letting all the speakers introduce themselves.
Hi, I'm Aaron.
Good.
All right, you want me to start?
Yes.
Yeah.
Okay, sorry. So I'm Aaron, and I'm here to talk about capability flavored effects today. So we've also got Alex and Jonathan who've been working on this, and also Lindsay, who's not here, but he's from Potanin. So the theme of this work is we're trying to understand what formal benefits we get out of capability safety. And in particular, we decided to look at effects. So just a little bit of background. The kind of setting that we're thinking about is maybe we're programming in a capability safe language. So in such a language, it prohibits ambient authority. So if you want to exercise authority over a particular resource, then you need a capability to do that. And someone else who has authority to do that needs to give you the capability to do that. So we're talking about capability safe languages in the sense of what Sergio Matthias defined them as. So no ambient authority, no amplification, stuff like that. So there's been work on the formal benefits of capabilities in different ways. So there's been a Hall logic that has a notion of if I trust this code to obey a particular spec, what is the risk involved in that? Things like that. They've been used to reason about what components use a resource. So the work with Demoulas involved using whitelists to figure out which particular components are exercising authority over which resources. And informally, you can kind of use capability safety to help enforce the principle of least authority. So to make sure that components are only using the capabilities that they need to do their work. The overarching question that we're interested in is, do capabilities help with existing formal reasoning? And the formal reasoning that we've chosen to look at is effects. So effects describe intentional information about how a program executes. So if we think about a type of a function that goes from unit to input, so units being used to denote either no input or no output. So this first function is takes no input and it returns an integer. The second function takes no input and returns an integer, but as it executes, it incurs some file.read effect. So there might be a particular file capability, and it offers you the ability to read the file, and as we execute this function, it's going to incur that effect. So this is a conservative bound, so it might not have that effect, but if it does have any effects, they're going to be the ones on the arrow. So effects are well studied, but some have perhaps suggested that the reason why they haven't seen much mainstream acceptance is because they're a bit verbose at times. So there are techniques that can help reduce the verbosity, such as inference, and those are those perfectly good techniques. And we'll contrast our work a little bit with inference. So sort of your typical inference will take a term, and in order to figure out what the effects of that term are, it might recurse into the subterms, annotate those, and then sort of use that information to annotate the term as a whole. So our system that we're going to describe is a little bit different in that you don't have to look at the subterms of the thing that's being annotated. You just have to look at the types. However, it's a lot more restricted in what it can infer. So a little bit different from inference, but it's also another perfectly valid technique. So the observation driving what we're going to talk about today is that if you track the proliferation of capabilities throughout a system, then you're also sort of tracking effects in a way. So this is the topology only bound in the sense of what De Vries described. So it's quite conservative, but it's got the benefit of simplicity, but you lack a lot of precision. So we're going to think about situations like this. Unfortunately, it's a little bit small, but imagine that we have a situation where there's some unannotated code and we want to execute it, and we don't know what it does necessarily, but we want to sort of execute it and maybe maybe we don't trust it, but we want to know if this violates our trust, then what's the damage that can be done. So in this situation, E is our arbitrary unannotated code, And E could be anything, so E might be a little script or something that you're running, or it could be a whole module that's been pulled from somewhere else, maybe like a third-party plugin or something that's offering a bunch of functionality. We want to run it. Well, we have to, in order for this to exercise any authority, we need to be the ones passing capabilities into it. So the idea is basically we can figure out what are the effects of this and get a conservative approximation on that just by looking at the capabilities that we're passing it as input. So in this case, we're just passing a log capability, which in this case is a function. So in our system, our capabilities there are a set of primordial capabilities, things that are sort of passed into the command line, and then there are functions which you can create which capture capabilities if you give them to them. So in this case, we're passing one function called log, which is a capability for the file.append effect. And so we know that sort of if this type checks, kind of the only thing that this unannotated code can do would be the file.append effect. And this first line up the top, this is sort of maybe the programmer declaring their intent. So this is saying, I want to execute this code E. I want to make sure that the authority that it has is bound by file.append, so it's not doing anything else. And here are the capabilities I'm going to pass in to let it do its work. And if there's safely type checks, then file.append should be a bound on what E can do when you execute it. So we can approximate. Yep.
So just to be clear, you're sort of implicitly assuming that E is a pure expression from the effect system's standpoint, that E can't forge any effects somehow, that the only way that it can cause effects on the world is through capabilities that have been passed to it.
Yep, so E has to be written in a capability safe language as well, but it may not be effect annotated.
Oh, okay, I see.
Sorry, yeah. So we can approximate the effects of that unannotated code by inspecting the capabilities that we give it. So this lets affect conscious code reason about untrusted, affect ignorant code and put a bound on what it might be doing. So the work that we've been doing, and it's partly still a work in progress, is to come up with a minimal lambda calculus which describes how this works and to prove it sound. So for the rest of the talk, we're going to be talking about some of the main issues that come across when you try to type check a piece of code like this, and how we've resolved it in our system. So let's take that example from before. Let's say you're importing a single capability called log, and the unannotated code you're doing just invokes it. In this case, to type check this code, the unannotated code has to type with exactly the free variables that are being imported. So generally, if you type something in a context, you can kind of add extra stuff to the context and it should still type. But because we're in a capability safe setting, we don't want that, because the extra stuff you add might have ambient authority. So we need to know that the unannotated code can type with exactly the free variables that we're importing. So in this case, just log. And then we accept the program if the selected authority, file.append on the first line, is an upper bound on the effects captured by imported capabilities. So this example type checks. We pass in a log, the only thing that has is file.append, and that matches what our selected authority is. Here's a more tricky situation. So let's say we're importing a log, but we're also importing something called pure apply. And this takes a function as an argument, and this function is pure, so the thing on the arrow is supposed to be empty set. So this takes a pure function as input and it applies it with maybe a default string. And the unannotated code is calling pure apply and it's passing log as an argument. So what are the troubles here? Well, first of all, if we look at the type of pure apply and we look at its input ignoring the effects is string to unit. And that's the same thing as the input of log, which is string to unit, again ignoring effects. The annotation on pure apply says that the input has to be pure, but on log it has an effect, right? But in unannotated code, you don't have any of the effect annotations. You just have these free variables called log and pure apply, and you know that they have a particular type, but you don't necessarily know their effects. So the issue with that is, well, if you're ignoring the effect annotations in here, then you're making pure apply have an effect that it shouldn't be having. So pure apply's signature says that it has no effects. Here we're making it invoke a file.append effect by passing it the log into a context where it's effect ignorant. So we have to prevent stuff like that. So we want to make sure that all the imports that we've passed into this unannotated code are allowed the selected authority. So in other words, if I pass in an input, then it needs to be allowed to invoke the effects that I've declared up the top. So this restricts quite a bit the sort of programs you can write, but it removes situations like this. So in order to do that, we need this notion of a higher order effect. So we can think of effects in this system as sort of, there's two kinds. First of all, a regular effect is one that you're kind of born to be able to do. So when a function is created, you might pass in some capabilities, and then the function has those capabilities and it can use them as it pleases. On the other hand, a higher order effect is one that it might gain later on during runtime. So perhaps the function takes an argument, and when it's invoked, a capability is passed through that argument, and the function can therefore invoke effects on that capability in that manner. So if we look at this code here, so it might be some setup code which does some stuff, and then at the end we create a new function called log. If we think about the effects here, this file.append effect, that's going to be a regular effect. This function, if this is well typed and someone else is passing it in, this function has been given this capability, and when it's created, this function is born with that effect.
Just the notation is making me wonder about something.
Yep.
On the file.append line, you write file with a capital F, which I normally think of as being about the class rather than an instance. Did you mean to be appending to? You mean clearly when you're appending to some instance. So it's just is that what is? Did you mean that line? Should I read that line as doing an append on an instance?
Yes. Sorry. So
okay.
yeah, that should be appending on a particular instance of,
okay.
of a file.
And where does that instance come from? I don't see it there.
So generally, you might this might be wrapped in a function which takes a file as an input.
In the outer scope.
Yeah.
Okay.
So in this case, the file.append effect is a regular effect, but the socket.append effect is going to be a higher order one. So when this function is created, it doesn't initially have the ability to do that, but later during runtime, someone might give it the capability for the socket, and then it can incur that effect. So if we have an annotated type tau, so a type with the effects on the arrows, we call that higher order safe for a set of effects epsilon if either the type tau doesn't take any capabilities as input, so maybe it's unit or integer or something, some primitive integer. So in that case, it's higher order safe. Otherwise, we look at its higher order effects, and those have to contain everything that we've selected for it. So perhaps easier if we go back to the example before. So in this case, pure apply, it's taking a capability as input, some string to unit that has a pure effect, or no effect rather. And in this case, the selected authority is file.append, and that's not contained in the higher order effects of pure apply. So in this case, we can reject this program for that reason. We say that pure apply is not higher order safe for file.append. Log would be higher order safe. So the input to log isn't a capability, it's sort of some string, whatever that is. A string were maybe sugar for some more complex capability, then we would have to do the same checks. But if we assume that strings are just some primitive type or whatever, then log would be higher order safe. So another situation is perhaps you want to execute this unannotated code and you get back a function or a module or something, and then you can use that function or module later on in some other code which is effect conscious. In which case you need to know what are the effects that could be incurred by the thing that was returned. So in this code example, we're doing the same thing, we're importing a log capability, and in the unannotated code we're defining a function and that's being returned. So we define a function called easy which just logs hello. And the thing to do in this case, the thing that our calculus does is that we just take the type of this, which is going to be an unannotated type. So in this case it takes no argument, it doesn't return anything, so it's going to be unit to unit. and we just annotate that arrow with the selected authority. So this is going to become unit to unit with file.append on the arrow. So this example will type check. You can get into trickier situations though. So let's take this code for instance. Same thing, same setup, we're importing a log. This time we're defining a function which takes a message and a socket, and it notifies someone on the socket that some logging is taking place, and then it logs the message. So in this case, this has a higher order effects socket.write, and so when we return this thing, we need to make sure that the annotation on the function has the socket.write effect on it. So if we just annotate it with the selected authority, it's going to exclude that effect, so that would be unsafe. So what we should do is, in cases like this, we should reject a program if the return type takes as input some primordial capability. So in this case, socket, something that's sort of passed in, just exists since the beginning of the program. And the effects of that capability haven't been selected.
Are there parameterized effects and effect variables, like type variables?
Yeah, we're looking at that work. It's the next slide, I think.
Okay.
Okay, so this example would reject because this socket effect is missing in the declared authority. Okay, so just as you can have polymorphic types, you can also have polymorphic effects. So same code might be instantiated in a different way to perform different effects. So this is an example I'm going to use for the next few slides. So up the top here, we're introducing an effect. We're saying that the effect write is a set of effects, file.write, socket.write. And then we declare a new function called write data. Takes sort of one effect variable, one generic parameter, which is called phi, and that's a subset of the effect write. It then takes a string and it takes a writer. So the writer is something which takes a string and it performs the phi effect. So it either writes to a file or writes to a socket, and it returns nothing. And all this function does is it just writes to the writer that you give it. So it's a bit boring, a bit contrived, but it's just to illustrate. And then to simplify things on the next slide, I'm just going to say that the name of this type is write data func. So write data takes either a file writer or a socket writer, or maybe something that does both. It's not excluded. And then it writes to that thing using the message that you give it. So let's say if we were to import such a thing. So let's say we're importing that write data function that we just defined, and we're also importing a file writer, and we want to execute some code in E. Now you could approximate the effects of write data by using the polymorphic upper bound, right? So write data has an upper bound which is this effect write, so file.write, socket.write. No matter how you instantiate it, those are the only two effects that can take place. But this you could do this, but there's a usability issue with this, which is that not all polymorphic types have an upper bound, and in that case you're not really getting anything useful. You're just saying that this polymorphic type has every effect. So we want to try and do something a bit more precise, and we can do this by sort of looking at the capabilities around the polymorphic import. So in this situation, we know that theoretically write data could take something that writes to a socket, and then it could invoke the socket.write effect that way. But we know that in this sort of context, the only thing that it has access to is the file writer. That's the only effect that is being passed in with it. So we could tighten the upper bound here. So we know that the socket.write effect can't ever happen in this particular body of code. And so we could get rid of that socket.write effect, and then we tighten the upper bound and we get a better approximation. So you kind of recover useful polymorphics in some way. So this example will type check, so for the reasons that I've given. So just to summarize quite early, we can reason about unannotated code by looking at the capabilities that it takes as input. So in a capability safe setting, you need to be given the capabilities in order to do anything effectful. And so just by looking at the capabilities that you give someone, then you can reason about what they might do. But there's some tricky stuff with higher order effects. So what we've done is we've added restrictions on the higher order effects that are allowed. So we've said that every input needs to be higher order safe for what you've declared. So it needs to be expecting all of the effects that you've declared that the unannotated code is allowed to have. So all that part up to the polymorphism, that's we have soundness proofs for those. With polymorphism, that's still a work in progress. So requires a bit finer reasoning to get useful polymorphism. We can't just use the upper bound because that's not very useful in a lot of practical polymorphic types and functions. So there's further work that we need to do to show that with polymorphism the system is sound. Or maybe it's not, but further work. Yeah, thank you.
So could you use the upper bound as a way of saying, for Markham's problem of underdevelopment, saying this is the most effects that this should ever get, and that would be a way of expressing a policy, and then maybe having a separate designation of what is actually in this implementation?
Okay, yeah. So it'd be like saying that whatever you pass in here is not allowed to exceed the upper bound.
That's right. And maybe a separate spec for what you currently are allocating.
Yeah, sure. Yeah, I think you could do that. I think
Would that help with your problem, Markham?
Yes, I think it would. I think that saying that don't pass me anything that is more powerful than this. I mean, having a language where you can say, here's an upper bound on the authority of things you can pass me. I think that sounds like something that would be very useful for trying to preserve security under maintenance.
I think that might have partly been, it might be different what you're talking about. That was sort of partly supposed to be the intent of this. So the thing is you might write, here's what I want this to exercise at most. Here are the capabilities that might be passed in. Make sure that these don't exceed the authority.
Yeah, but even though I know this version would never have a socket right, how do I designate to the guy 2 years from now that this should never get a socket right? Well, just putting in the upper bound would do that. Right? But then you'd probably want to also have an actual bound for this version of the code.
I see, yeah.
Yeah, I was thinking about, going back to the slide where you have the phi, this one, phi subset of right, where right is the upper bound. By being able to, when you do type parameters, being able to do the type parameter and state an upper bound, where the upper bound is really an upper bound on the effects it can have, I think that might be effective at catching early a lot of mistakes that would have destroyed your security. The issue is, the issue is, given the ability to express something like this, when people use it to express those limits by using the upper bound mechanism to express them.
I'm kind of confused. So there is this body of languages which were doing information flow control, like eRights.org, and they have labels in the type system, and the code which tries to assign incoherent labels essentially doesn't type check. This looks really similar. So what's the relationship between this work and yours?
So let me say as a challenge to the audience and all object capability researchers, I am deeply confused about the relationship between information flow, formalisms and languages, and object capabilities. Part of the reason for my confusion is that the focus of object capability work is primarily on integrity. The focus of the information flow work is primarily confidentiality, and the thing they call the dual of confidentiality, they use the term integrity for it, and it has nothing to do with what an object capability programmer means by integrity. But there's been very, very little work trying to explain how these things relate to each other, and does one subsume the other? Is there some kind of, what kind of mapping do they have? Because clearly they're both about overlapping concerns. Toby Murray, I would certainly refer anybody who's interested in exploring how these things relate to Toby Murray's papers, which I interpret as using information flow as a higher level set of specification constraints to check the object capability code for correctness against. Not to use information flow as an enforcement mechanism, but to use it as a compact language for a restricted set of constraints that's useful to check the code against.
But I don't know, my observation is it gets really close at this point. Like all the ethics, they look really similar.
What were the names of the languages
Well,
that you
GIF is the most
GIF is the security one, but GIF is about analyzing the languages that already have written the code and expressed the way they wanted it without capabilities, what they intended for information to do, and then GIF sort of analyzes what it can best with what it has about the Java-based programs without capability assumptions, without anything, and then use effects and constraints to actually figure out what it can about the information flow. Here you have a language which has first-class modules which are capabilities already there, that's assumed.
I thought, maybe I'm misinterpreting GIF, but if I understand correctly, they have a static type system, right, which allows you to check that label A will never reach whatever file, which means there is no affect, right?
So there, I think there is a crisp. I agree with Mark that the general question of capabilities versus information flow is not well understood. I think for your specific question, there is a good answer. Effects are really about what you can do, what actions you can cause to have performed. Okay, which is I think what Mark means by authority. It's this is an approximation of authority, restricted to a particular set of built-in effects in this case. Whereas information flow is all about can information here be affected by information here in some way. It's an interference property. And so in particular, with information flow, you have to reason about, do I take some information and put it into the heap and then get it out later? That would not have, if an effect system would not have anything to do with that, because it's just about what its effects are in the control flow of this particular execution.
It's also about, information flow control is also about the provenance of the data. So you might tag something coming from outside as different from something you created inside, and then feed it through the same function. And information flow would track it, and I don't see how capabilities would
In
do
the end,
that.
when I actually building a key value store, my goal is the same. The data with the wrong label never reaches the network. So it's very similar to your effect system, which says, okay,
But the effect system says you can never use the network at all, not that you can't only use it in certain cases.
Only for certain data. It's the data that gets tagged in
well,
information
but I
flow
think it's
control.
that effect system is then a subset, because here I can even distinguish which files it can write to, right? That's a more verbose. If you need to write into a file, but only to a specific file.
But it doesn't, you have to structure your program to allow that to happen based on views, but with a GIF or something like that, you're basically saying, no, it should never be possible to flow into here, and it just stops it, right?
Well, GIF says if it came from here, it can never flow from there,
Right.
but if it came from here, it can flow through the exact same code and end up
So
there.
it's more enforcing, whereas with the capabilities, it's about structuring your code if you want to allow those different possibilities.
But the capabilities aren't data specific, and information flow control is.
We should probably talk more, and I'm a systems person, so I'm not like a hardcore language person. But if someone can explain.
Mark, do you want to clarify that integrity versus confidentiality distinction, or is it impossible to do?
Since we've now.
During the break.
But let's do it during the break. To a first approximation, I think I can say something quick about the dual of confidentiality to an information flow is that something not known to be good does not influence something good. And what integrity means to an object capability programmer is essentially invariants are maintained. is that things are not corrupted. And you create abstractions all the time, which an information flow person would say, this is it has to be an endorser, because it has to remove the integrity taint. But you create abstractions all the time that are defensive, that can take input from untrusted sources and react to it in trustworthy ways and maintain integrity, preserve its invariance. So as soon as you have endorsers everywhere, you're effectively not using the information flow system. I think I'll stop there.